Gavin, welcome to Ngā Whare Pārara, New Zealand's first climate positive superhome.
Thank you, Bob. It's a pleasure to be here. I'd love to learn more about it. Very, very happy that Weathertex is going on the wall. It's a great thing, but tell me more about the wall.
Yeah, so this is Eco Panel, which is made off-site in a factory. Dan Saunders, who's the builder for this project, also is the owner of Eco Panel.
Right.
And that's sort of our go-to wall system.
Yep.
And the beauty of this is it goes together very quickly. So like 2 or 3 days ago there was nothing here, all the piles were here in the floor, but so the house goes together in a matter of days, nothing gets wet, and then we just put the structurally fixed cavity
it's a full wall
battens on
cavity already completed.
Yeah, so it's already got the insulation in. Usually it comes, or sometimes it comes with the battens already on.
Okay, as well, yep.
Well, this one's got the battens on the inside because we do a services cavity on the inside for the plumbing and electrical.
Yep. And then the exterior battens are horizontal or
so
vertical?
Horizontal
yep.
with castellated battens.
Yep.
And
that saves your timber straight up.
Yeah, so this job we're using the 40mm thick battens. And
so it's a structural batten?
Yeah.
Yep.
So we don't need timber in the wall cavity, so we don't need any dwangs, so we leave out the dwangs, which is, what do you call them in Australia? We call them dwangs.
Yeah,
or noggins. Yeah,
yep.
So North Island they call them noggings or nogs. But
yep.
So, and we don't need to fix the claddings into the structural timber.
So you'll hang the cladding off the batten?
Yeah, so the cladding basically is just fixed to the batten. So there's less penetrations through the wrap.
Yep.
There's less thermal bridging because you've got less timber in the wall. So yeah, we've sort of thought this through. In New Zealand, there's probably, or there's definitely more timber than is needed.
Yeah.
There's about, on average, 34% structural timber to insulation ratio. So it could be 50 or more % of the wall is timber. So that really reduces the thermal performance of the wall. They had assumed that it was 14 to 18%, but it's actually a lot worse than that.
And what's the width of the cavity?
So this job here is a best level superhome, so it's equivalent to passive house standard.
Yep.
And we've worked out that we had been doing 140 thick, 140 studs and a 45 cavity, internal cavity. But we've worked out on this job in Christchurch climate, we only need a 90mm stud and a 45 internal cavity.
Yep. Yeah, internal cavity,
yeah. So, interesting.
And how long would it take you to build something like this with the cassette type walls? If you're just building one instead of 4.
Yeah, so if you've already got the floor down.
Yep. So floors down, pylons are down.
Yep. Or if it's a slabs down, and then which is most houses. This one's got the timber floor because it's net carbon negative.
Yep.
Most houses in New Zealand have concrete slabs, but so if the floor's down, it's a matter of days, like less than a week for the house to go. 2-story house, roof on.
So it's roof trusses as well. Yeah. Wow, that's pretty amazing. Yeah.
And nothing gets wet.
Yeah.
So traditional on-site in situ timber frame construction, it could be weeks, months out in the weather.
Yeah.
Do you want to have a look around?
Yes, I'd love to.
Yeah. So this house here is going to be 2-story. The second story hasn't gone on yet, but this is all Weathertex.
Yep.
Smooth with concealed fixings. There's a little bit of a coir on the gable end here, just because we're a double height.
When you say concealed fixing, you're countersinking a screw and filling it?
Yep.
Yep.
And then the garages are separate, and then there's a combination on these houses, there's a combination of natural,
natural, weatherproof.
And we're not coating that, we're just going to let that weather.
Let it weather off, yep.
And then
no maintenance.
Also painted with the vertical Weathertex.
Yep. The Woodsman as well, or smooth?
Smooth.
Smooth. Okay,
So,
with the
yeah.
pre-primed,
So-
ready to paint.
Yeah.
Yeah.
So there's 3 different finishes here,
Yep.
and 2 different Weathertex products and different methods of fixing. So
Yep.
with the natural, we didn't do the jointers because we want to
Yeah, so the double
leave it uncoated.
studs,
Yeah.
DPC,
Yeah.
secondary gasket, and then
Yeah.
away you go.
So we've thought it through, and like I said before, number one for us is its aesthetics,
Yep.
and then fairly close to the top of the list is carbon, and the Weathertex is carbon negative.
Negative,
So,
yep.
and also it's recyclable, so we love that.
Yep.
We don't have to worry about toxic chemicals. We can just mulch the waste and
Yep. Put it on the garden.
Yeah,
No cutting rooms required. Can
Yep.
cut the Weathertex anywhere.
yeah, that's important to us.
Yep. No silica.
Because waste is actually carbon. Everything you throw away, first of all, you've had to pay for that, but there's carbon involved in producing it in most cases. So if we can reduce the waste, it's good.
Yep.
And then if we can stop stuff going to landfill, that's really good.
Yep. Something to consider then, Bob, is we have a system where you can send us your plans and we'll do a takeoff for you, and we will reduce waste even further. So if we can use a cut-off under a window or above a window where we've had to cut something around the other side, we'll actually colour code the elevations when they come back to you.
Yep.
So, because we're trying to reduce that waste ourselves.
Yeah, cool. Yeah.
Yeah.
We actually did colour-coded elevations, looking at the different
did it yourself. Yeah, okay.
different materials and the different lengths and sheet sizes, and that's really cool because with the different sheet sizes, we've got less waste.
Yeah, yep.
And
Yeah.
so this one here, we've got these little sort of returns.
Yeah, is there a reason for that?
Yeah, just there's a change in cladding, and we don't like seeing the cladding change on an external
On an
corner.
actual corner, yeah.
So
okay.
we have a little
Yeah.
a little dit, a little
Yeah. So it's not a sustainable thing, it's just more an aesthetics thing.
aesthetics thing.
Yeah. Yep.
And that wraps over to the roof. So the fascias are Weathertex,
Okay.
and they've actually got the fascias on there at the moment.
Yeah.
So we're doing all the barges and fascias in the Weathertex.
Yep.
Basically, because we needed a thicker fascia because we've got more insulation in the roof,
Yep.
and that was the option that we went with. And this is the first time we've done it,
Yeah, okay.
but
Yep.
it worked well for the design.
Yeah, nice.
Yeah. But yeah, they're just geeking out over the big battens.
Yeah, okay. So that's your 45 by 45, is it?
40 by 70. Is that 40 by 70 castellated?
This one is, yes.
Yeah.
Oh, 40 by 70.
Because
That's not standard, is it?
no, the foreman on the site wanted a more solid batten.
Okay.
So that would be the 40 by 40, wouldn't it?
Yeah.
40 by 45.
So here we've
Yeah.
got 2 different, so there's obviously,
He wanted something more solid to fix into. So,
Right.
because what we find sometimes with the 40 by 40 or the 45 by 45 structural cavity batten is that you get some bounce with it.
Yeah, okay.
Even though it's still a structural cavity batten, you
Yeah.
still get some bounce with it, especially like when you're doing, say, the vertical timber products and stuff like that.
So this ITI, we're able to supply these because this is RK.
I was going to say that. Is that a standard product or does it have to be ordered?
Standard from these guys.
Standard from
ITI NZ.
So
Okay, yeah, that's
likely
excellent.
what we'll do moving forward is we'll move away from the 45 by 45 and just use a 70 by 45 all the way through.
Yeah, right.
Just because it's a lot more.
Yeah,
Yeah.
a lot solid.
So what you find is, the reason why we have it obviously as a 45 mil is we eliminate the dwang behind it.
Yep.
But what's happening is our fixings that we fix our cladding to, regardless of what it is, if you're using a 20 mil castellated batten and a dwang behind it, all you're doing is penetrating your weather tight wrap every 150
Yeah.
seconds.
Yeah.
So what this does is eliminate the dwang behind it, which gives us continuous insulation. It also prevents us
stops you
from
popping holes.
in this.
Yeah. Makes sense.
Yeah. I mean, it's good to have this conversation because there's a lot of little things that go into building these type of homes, and each project we learn something new, and then we carry that forward to the next project. So each project's better than the last one because we've learned something.
Yeah.
But do you want to have a look inside?
Yes.
So this
it's considerably cooler inside.
And quieter.
And quieter, yeah. Lower the level.
Passive.
Yeah.
Passive.
So this one is
No aggression.
this one's got 3 bedrooms and 2 bathrooms upstairs, and then there's one multi-use room. It could be a bedroom or it could be a second living space with a media room or an office, however people want to use it, and another bathroom. So all of these houses, they're quite compact, but they've all got 1 bedroom and 1 bathroom on the ground floor.
Yeah.
And they're all designed for universal design, which is all about accessibility and wider doorways, level thresholds. So when this is finished, there'll just be a channel and grate, so straight in, no steps.
Put Nana downstairs.
Yeah. Or if you break your leg, you can still have a bathroom and a bedroom on the lower level. Yeah. So they all have higher ceilings in the living spaces. So this one's a bit smaller. I'll show you the one next door next, but that's the biggest house. And that's got a slightly different layout, but the reason for this higher ceiling is probably a couple of different reasons, but the main one is we designed this so that the sun can reach the house behind. So they're partially 2-storey, and then with a area that's single-storey, so that the outdoor
Not
living,
completely blocked
the
from
house
the sun.
itself and the outdoor living space gets sun for more of the day. But this will have plywood, grooved plywood on it.
Oh, yes.
Yeah. So there's 4 houses on this site. It's a typical quarter acre site, 1,000 square metres, and your average greedy property developer would have 7 houses on here. So there'd be
no direct sun or no direct light coming through.
Yeah, so it'd be multi-res. There'd be another house in this gap instead of a garden.
Yeah. Are you bringing down air from the?
So this has got a balanced ventilation.
Yeah.
Heat recovery. So this is all.
That's coming out of the roof.
No, that's coming out. That's balanced. So that's not. So there's positive pressure and then there's balanced. This is balanced. So the positive pressure is the one that I was talking about, where there's a couple of companies that do. They just basically have a fan in the ceiling which sucks in the air from the ceiling and pushes it in and basically blows up like a balloon, but the balloon's got holes in it.
Right.
Should we just shoot upstairs? I can show you where the ventilation is up here.
Okay.
Whereas this one is like blowing up a balloon with having one in, one out, so it's balanced. Yeah.
So
That's what you mean by the balance part.
Yes.
Yeah.
So it all comes back to here. So the unit will sit in here.
Right.
And the hot water cylinder sits in behind, and then there's a unit here. So all of these ducts run in a cavity. So there's a 90mm cavity between the roof truss and the ceiling.
Yep, between first and second floors. Yep.
So this is all inside the thermal envelope. And then the lower level, there's a 90mm cavity between the floor joists and the ceiling. So all of the ductwork can run anywhere in the house.
How many vents do you have that coming out in?
Every room.
Every room.
So so that'll get cut off at flush with the ceiling, and there'll just be a little grill on there. Yep. So every bedroom, living room has fresh air. All of the bathrooms, wet areas, kitchen have extracts.
Yeah, that's cool.
Yeah.
That's great.
There's just two bathrooms, one with a bathtub.
Yeah.
And then
decent sized bedrooms as well.
Do you want to have a look at this, just as an example of what we're talking about with the high density building? So if you see those units over there?
Across there.
So they've got basically no sophites, obviously keeping costs down. So more materials, more labour by doing that, but there's no protection for overheating in the summer. Yeah. So what we're talking about, having a house in between, see these eaves here, the eyebrow just above you, we're getting protection from that, especially that high summer sun, where that's where the most of it, the heat's coming from, you see.
And we've actually, really uncommon, but we've actually got that on the lower level as well. So there's a little eave running all the way along. If you look down there.
And what are they, triple glazed?
Yeah, these are triple glazed, specifically down there.
Oh yeah, rightio.
Yep.
That's the shading down there.
So normally in a two-storey house you have no shading on the lower level.
So, and with say the thermally broken aluminium or even just aluminium, you feel both sides of that.
Yeah, mate, there's a massive difference.
Yeah, right.
Yeah, massive difference.
That looks like some nice sustainable Weathertex on the fascia over there, Dan.
Yeah.
Yeah.
Yeah, that worked out really well. And
300 smooth.
Yeah, we've got 300 smooth on all of the other houses and the barges and fascias. Yeah.
And you guys have like calculated how far that eave needed to be to create that shade for that window.
Yeah, so they do thermal modelling basically on the computers.
Yeah.
Which works out obviously
depending where the sun is and what your angles are.
Yeah. So this house here, we'll go and have a look at that in a minute, but that's the best house. It's the biggest. It's a standalone home with a detached double garage, and it's got a bit more space in the living room. But that was, I think, it had 1% potential for overheating. In terms of the passive house standard, you're allowed 10%, but 1%. Technically, but it's never going to overheat because it's so well designed. But yeah, it's your best guess, the energy modelling, so we know how it's going to perform through our experience, but the energy modelling is just verification of that.
Yeah. It's a double garage here as well.
Yep. So in this house, the ventilation unit sits here.
Yeah.
And then there's
this is the in out.
yeah there's a heap of ducts that go through this bulkhead here.
Yeah.
And then there's kind of a manifold above the pantry over here. So this is the kitchen.
Right.
And then so your supply ducts go through to here, and then like that spaghetti junction with all the green ducts.
Yeah.
There's a manifold in here that. That's got a lower ceiling because of all the stuff that's up above there. And then,
it's considerably larger, isn't it?
Yeah, like the other house, there's ducts in every space. So there's a bathroom in there, it'll be extracting from there. And then, so even in here, there's a duct here. Because eventually this will have glass here, so there's a borrowed light, so you get light through over the top.
Yeah.
So this space here is your multi-function room in this house. So this could be the second living.
Yeah, sitting room, reading room, whatever.
And the extra bedroom, there could be a bed that pulls out from the wall, sort of thing. And if someone needed a bedroom on the ground floor.
And does the void help with the airflow and being able to keep the house cooler or warmer when it's required? The higher ceiling?
Yeah, I think to a degree it does, because you've got more air volume.
Yeah.
But the house is going to be beautiful and constant temperature regardless of what the weather is doing outside.
Yeah.
It's got the triple glazed windows.
Same with the doors.
Yep, doors are the same.
Yeah.
And it's actually got underfloor heating, so there's water pipes in the floor.
Okay, so warm water.
Yep. Or, I don't think you even need it because it's never going to get too hot because of the design, but theoretically you could run that in reverse and have cool water going through the
as
pipes.
well, if required,
Yeah. But, global warming, we've got a design for a changing climate.
What's coming,
So if you needed to, you could run it there.
And will there be a floor covering, or will this be polished concrete? Or?
No, this has got timber overlay floor.
Okay, yep.
But there's very little heat input required, so it's kind of luxury really, just having the warm floor.
Yeah.
And then there's a dual system, so the heat pump that heats the water for the floor also heats the hot water for the house.
Right, for your showers and your kitchen and...
Super efficient.
Yeah, right.
Yeah. So that's probably one of the big breakthroughs, actually, how that works with the space heating and the water heating, and powered by solar panels. So all of these houses have solar panels.
Yeah.
So basically all of your heating for your hot water and your space heating is free because it's coming from the solar.
How many panels, what sort of system you have on the roof?
There's 16 panels, they're about 500 watts.
Yeah.
There's a hybrid inverter, so they're not set up with batteries from day one, but someone could add a battery
If
to
they
it
wanted
because
to,
it's got the right inverter for that.
Yeah.
But what we're thinking is the V2G, vehicle to grid, that might mean that people actually use their car as the battery for the house.
Yeah, right.
So that's why we haven't put batteries in from day one. We thought, well,
You might need them.
the car will be the battery going forward.
Yeah. Yeah, I can't wait to see the Weathertex on them. They're going to be fantastic.
So this one here, there's ply on this wall and ply on the ceiling.
Okay,
and,
yeah.
Just
What
so
sort of
it's-
ply?
What sort of ply, Dan? So the ceiling's got grooved ply.
Yeah.
It'll just be decorative ply. It'll be like New Zealand pine.
Like 10 mil sort of thing.
Yeah.
Yeah, so 12,
Pinus radiata.
12 mil on the ceiling.
12 mil.
BD
Yep.
grade or a CD grade.
Yeah.
Not
Yep.
CD, sorry, BD. So that'll
Yep.
be staying.
Yeah.
And then these reveals, the plan is to mitre them, and we're just going to have a little aluminium trim, so you won't even notice it. It'll
It's
just
like a little back flashing almost.
it's really a tile trim, but it just takes care of that
yeah,
corner.
yeah. Yeah.
But yeah, it's good just to have a bit of biophilic vibe, bit of natural wood.
Yeah. Give it a completely different look to what you've got in this section of the same room.
And then the sophites, if you go outside, you'll see the sophites are already on, but they're grooved plywood as well.
Okay, yeah, I did see that from upstairs out here.
Yeah,
Yeah.
yeah. And then upstairs, you might have to not walk in the bathrooms because I think it's got a wet floor.
So do you expect that these homes would use less electricity than a normal home as well?
Absolutely. I think probably likely no electricity. Definitely the front house, zero energy, zero carbon, zero energy.
Yeah.
So this one will be near zero.
Yep.
Yeah. So there's a ensuite and there's sort of a walk-in closet and an ensuite around there.
Yep.
So this is really effectively the master bedroom. So they've all got these recessed sort of niches, or probably more than a niche really. It's like a recess the whole length of the room, and then there's a shower and a bath at that end. And so those have like a LED light on there.
Oh yeah, strip lighting.
Yep, and then the back wall has strip lighting, so there's a feature tile on there and a feature tile on there, which is lit up by an LED strip.
Yep.
So that'll look quite slinky.
Yeah.
Illuminating.
Yes.
Relaxing.
Quite, swoopy. So there's 3 bedrooms. These ones are a little bit smaller, but they're still reasonable. This is what the windows are going to be on the front house. So it's got this wood
Oh yeah.
veneer. So these ones have just got the wood on the outside, but the ones at the front house will have the wood on both sides.
Okay.
And then there's a colour on the inside. So effectively they look exactly like timber windows,
Yeah.
and they all do that.
I love that.
Totally.
That's a really good option to be able to do that, just to let some fresh air through.
Yeah.
But I suppose you probably don't need it with the system you got running anyway.
Probably not, but
No.
it's good to have the option.
Yeah, exactly, yeah.
And the doors do the same, the French doors.
Oh yeah.
Yeah. So they can all tilt. They're covered up, they're masked at the moment, so we can't really do that. But yeah, all of these doors can just tilt in. And then this has got the best outdoor living space too, so there's about sort of a 10 metre by 5 metre space out there.
Area, yeah. So is the fact you can do that with the doors just because they're PVC and they're a lot lighter?
Yeah, they're probably not that light with the triple
With
glazing.
triple glazing, yeah.
But it's just the hardware is really good.
Okay.
And the other thing about these doors is the hardware is, it's got multi-point locking, so there's about 6 points where that is locked, sort of latched together. So it's really
so they're quite
airtight.
strong. Yep.
It's got triple seals. Basically, the whole door or window is sucked in, and so it becomes completely airtight. So a lot of the windows in New Zealand, well, most of them are aluminium.
Yeah.
But everybody thinks about and talks about the R value of the windows. Nobody talks about the airtightness of the windows.
Yeah, right.
So the European windows, they really thought that through. They're super airtight. The New Zealand, typical, the sliders are the worst, but they're really air leaky. And some of them, a lot of them have holes drilled through the aluminium so the condensation can drain outside.
Yeah.
So they're just
screws.
They just leak like a sieve.
Yeah.
So that's probably the biggest con in New Zealand building is, I don't know about Australia, but we've put up with, the consumer has put up with particularly crappy windows for a very long time.
Yeah, they're always the weakest point of every house.
Well, they are. It's like a hole in the wall, but these windows, these are 1.2, really airtight. The best ones with the best glass are 1.5. So the walls in New Zealand homes, the minimum standard is R2, but by the time you factor in half of that's timber, it's more like R1.2. So these windows are as good as a New Zealand wall.
Yeah. Yeah.
So it just opens up the possibility to you can have light, you can have sun, you can have humans like sun and light, and we respond to that.
You can move around.
Yeah. So you don't have to have small windows to have an energy efficient house if you have these windows. It just opens up possibilities design wise.
And everyone always says that. You've got to have smaller windows, less windows. Yeah. Then you got less light, less sunlight, less warmth.
It's a con.
Yeah.
If you get the design right, you don't need to have small windows.
Yeah.
Pity there isn't more Weathertex on, but we can come back and talk about the Weathertex when we've got it on. But I mean, it's going to be a big part of the story of this project, the Weathertex, and this is really quite a foundational project because we're going to be using a lot of it going forward, I think.
Great to hear.